what is the thing that we want to address? What is the challenge that's facing us? And when it comes to climate, obviously, we've seen in the last few weeks, in the last few months, all of you have seen, read about the extreme weather, kind of that level of whether it's the heat domes or if you're in the southern hemisphere, obviously it's going to be a different picture. But everything from the levels of sea ice, the poles, or the ocean temperatures. These are kind of just a few graphs from the June temperatures from the project called Berkeley Earth, which is at Berkeley University. Basically, just everything that you look at, there's massive anomalies happening in the last period across all the different measurements. And that's just basically telling us what, we already know, but we know that the trajectory we're on is not great. It's not sustainable. And essentially, what it's just telling us that the importance of taking action and taking action as quickly as possible. And taking action has to be at a global scale because, the thing with climate is one of those things where, unlike something like, access to clean water, for example, or air pollution, these are things that if they're happening, if you solve it in your country, then you're fine. What happens in another country doesn't really affect you. You might feel bad for people who are suffering under these conditions elsewhere, but it's not going to affect you. But the thing with climate, it doesn't matter. If one country gets its emissions to zero, it's not going to matter unless the rest of the world is doing the same. Or at least the vast majority of the rest of the world is doing the same. So this is probably the best example of something that requires really concerted global action, that everyone across the world, that kind of all companies and governments really take action together to be able to get things under control and kind of ensure that the planet remains in a good condition for everyone and kind of have that sustainable future. So, I don't like to kind of go on, this is like, it's all of these bad things, but it's about that it's a real challenge, but it's a challenge we can overcome. But to overcome it, we all have to put our talents, our skills, kind of think about how we can make a contribution, whether it's at an individual level or by joining organizations, companies in the future, by what we study, by what we think about. And so it's kind of just to set the scene of where we are now. So, when we come to kind of trying to visualize and understand what are the challenges in climate change, what are the challenges around greenhouse gas emissions, I find this is one of the best graphics out there. Although the state's kind of using numbers from 2016, things haven't changed. Like the broad parameters are correct, right? There's been a few changes here and there, but it's not that different. But I think this is one of the best visual sort of representation of what's really happening and what we need to change. So as you can see, energy is the vast majority of emissions come from energy. But energy is a lot of different things, right? So energy is the energy we use, the electricity we use at homes, the petrol we put in cars, the coal-fired power station we use for electricity, all of that. It's also, industry. And industry and things like, how do we make steel, for example, that we use in everything or in so many things around us? How we make chemicals, whether it's chemicals in anything from soap to glue to industrial chemicals. There's lots of food and so on that results in that. It's also the energy used in agriculture, for example. So there's so many things around energy, and energy obviously is one of the things that have been tackled the earliest. So we've had the lots of renewables being deployed around the world, but nowhere near as much as we need. We need so much more still. There is the electrification of transport of cars that is starting to happen. Again, very early days, but at least we can see where this is. We can see what the solution is. Things like aviation and shipping are much harder to decarbonize because just having big enough batteries that can make a plane fly is still a challenging problem. And then we have things, you can see there's the next big thing is agriculture, forestry, and land use. So this is things like when you burn crops, which is something that happens across the world to make place for new crops. And deforestation, of course, but also generally speaking, sort of a lot of things around agriculture that does result in a lot of emissions. And then the rest, you can see things like chemicals and cement. So cement, we're going to talk actually about cement in a bit more detail. It comes up here as 3%. The real figure is somewhere between 6 and 8%. And the reason for that is that some of it is energy to cement, and the other is something called process energy, which is essentially CO2 that's released in the production that's not related to energy. And I'll talk a little bit more about that. But this is the challenge and the things we need to address. And broadly speaking, things like industry, heavy industry, so steel and chemicals and cement and all of these are things that have not had as much progress as things like electricity generation, which at least we know there's that move towards renewables and the battery storage and so on. So we get to AI, right? And we say, okay, so we know that AI can do lots of things. AI is very powerful. Now, I want to talk about ChatGPT here for two things. One, to say, first of all, it's an extremely powerful tool. And I personally, I have a ChatGPT Plus subscription that I use at work. It's very useful to me. It's very useful to do, for example, early research into something or kind of brainstorming ideas and so on. With things like there's a tool called Code Interpreter that was released recently with ChatGPT that enables people to do data analysis very easily and also like to correct code and review code and so on. And some of the tools that are connected to ChatGPT will make it even more powerful. But it's important to also know that things like ChatGPTs and like large language models that we hear a lot about today are only a small subset of AI that are good at lots of things, but in some things they can't do anything really. And so this is a bit of an exaggerated example, but if you want to finish the construction of a building, yeah, you can spend all the time you want with ChatGPT. It's not going to get you very far. And the same with climate. There are things where tools like LLMs and ChatGPT can be useful in the climate space, but there are many, many other things where they're just not the right tools. There was a comment around ChatGPT and mass calculations. No, and actually, I mean, it could be made, right? It could be connected to something like, there's a plugin for ChatGPT called Wolfram Alpha, which makes it very good for math. We could also just use Wolfram Alpha straight away, right? But the way it's set up is not really to do math. I mean, they could do it to do that, but they haven't done it, at least at this stage. I spent quite a bit of time trying to find a graphic that represents AI. And the problem is like every single graphic you look at is completely different from the next one. And it's because it's such a broad field and you can cut it up in so many different ways, right? You can say that, yes, there is machine learning is part of it. This one, for example, has computer vision separate, but many people say computer vision could be also classified as a subset of machine learning. You can say natural language processing, which is large language models came from that, which is the processing of text and understanding of language. But all of these could also be parts of things like knowledge representation and reasoning, which you can see on the left-hand side under components of AI. So there's so many different ways of cutting this thing. But kind of the point I want to make here is that if you think of things like large language models, they're good at understanding or getting kind of context from text, being able to use them for kind of all the applications that ChatGPT does. But they're also good at things like computer vision, recognizing things in images and video. Now, the diffusion models that you may have heard about recently, like things like Stable Diffusion or Midjourney for producing images, videos are coming up or starting to come up these days. And, over the next year or so, we're going to find like incredible abilities to produce videos just from prompts. And there is then kind of other fields. And one of the ones that, that I kind of just want to highlight, there's a lot less to talk about, is time series processing, time series analysis, essentially things that any sort of AI system that deals with data, so with information really that is time dependent. So the thing with texts, even with speech, even if you're kind of processing someone talking for 30 minutes and you're processing that, or with audio and video, the information in the next frame, the information in the next minute is not dependent on the one in on the time frame before that, to an extent, in the sense that you have that already, that video or that audio or that text, and you're kind of just applying AI to that. With time series, it's essentially things when something is happening in time will have an effect on something else. So this comes, to illustrate that, for example, if you think of a chemical reaction and you heat up water in your kettle, and in second 1, it's going to have one effect on the environment around it. In second 15 and 60, and after 2 minutes, it's going to have a different impact because the heat is increasing, the system is changing, the water is boiling, there's vapor coming out. So depending on when things are happening, have an impact on each other. And that's perhaps simplification of time series. And kind of the reason I mentioned that is that generally speaking, you find there's been this huge focus on computer vision and imagery and language processing and language understanding. So quite a lot less on things like time series. And the reality is the vast majority, or at least a lot of the big problems in climate that AI could help solve, are time series problems. So there's still quite a big gap in that. Now, going to cement, I'm assuming everyone knows what cement is. Just gonna check if, anyone is confused about the difference between cement and concrete. I'll go over it quickly. So cement is the stuff you see in the left-hand side. Actually, I'm not sure this is cement, but anyway, it looks a bit like that. This is a cement plant. So the stuff you see on the left-hand side picture at the top is essentially cement. Looks like that. It's a powdery thing. It's gray, and it's essentially the binder. It binds different things together. And then concrete is what you see getting poured in construction site. It's the stuff, it's also gray, but it's the stuff that basically makes up walls and floors and so on and becomes solid. And so concrete is made up of, in large proportion, of cement, but also water and things called aggregates, which are small stones and rocks and so on. So the issue with cement is that, one, the world produces 4 billion tons of cement a year, right? So 4 billion tons, just to put that into perspective, that's 4 trillion kilograms. So it's an absolutely massive amount. Concrete, which is made up of cement and other things, is the second most used material on the planet, second only to water. You can see how immense the amounts of that stuff that we produce. Now, just to kind of very quickly, how we produce cement is we take limestone. Limestone is a sedimentary rock. It's the most abundant sedimentary rock on the planet. It's a bit everywhere. You take it, you crush it, you heat it up to 1500 degrees Celsius. And then on the other side, you get something called clinker. And clinker is essentially an active ingredient in cement. So what's very interesting about that is that this process of taking limestone and crushing it and heating it up to produce clinker is responsible for about 6% to 6 to 7, depends on what you look at, between 6 and 8% of all global emissions. So there's just this one chemical process. And it's very, very difficult to change. Very difficult to change because it's very difficult to produce temperatures of 1500 degrees Celsius. You can't really do it with electricity today because you need a continuous process and don't have the kind of power that is able to generate that. And because more than half of the emissions come from essentially limestone, the chemical composition is roughly CaCO3. You heat it up, you release, essentially separate the calcium oxide, CO, and what's left is CO2, and the CO2 is released into the atmosphere. And the reality is it's very difficult to find a replacement for cement because it's everywhere, because it's cheap, because it's very versatile in how it works with concrete and buildings and building everything around us. So then where does AI come in? So this is the company I co-founded, Carbon Ray, and essentially just kind of a representation of what it does. So about 40% of the emissions in cement come from the fuel that you have to burn to get to these temperatures. To get to a temperature of 1500 degrees Celsius, you have to burn a lot of coal, essentially. Well, at least today, that's what most people do. Most manufacturers do. They burn a lot of coal, a lot of other fossil fuels. Sometimes they try to replace that with alternative fuels, so other things that are lower in carbon, but still a very significant amount, 60, 70, 80% is still coal. And so one of the ways to reduce that is to actually make that process more efficient. And making the process more efficient means that you don't burn more than you need, but also you don't burn less than required to have the right quality. Because if you have low quality, you end up essentially having to make up for it by making more of the stuff. So it might sound like a relatively easy problem to make something more efficient. Actually, the reality is that the industry has been trying to do this for about 30 years. And it's an extremely complex problem from physics and chemistry point of view. So essentially what you need to do is you need to look at the interactions of a lot of chemical reactions happening when limestone is transformed into clinker. And you need to do that whilst looking at the type of fuel that you're using, the heats that you're using, the airflow, things like the efficiency of the combustion, how fast the rotation of the equipment is. And all of these essentially create a space of probabilities, so a range of probabilities of what the optimum settings are that is essentially impossible for a human to compute. It's also impossible for traditional sort of data analysis techniques to deal with. And AI really, or machine learning really is the only way that you can reduce the complexity to something that makes it possible to say, actually, for these conditions at this point, with these inputs, these are the optimum settings that allow us to get the most efficient thing possible. Now, if you can reduce the amount of fuel that's used by 10, 20%, that in itself, imagine if you could do that. Obviously, it's very complicated to do that. There are lots of other challenges, but if you did that across every cement plant in the world, you would be able to reduce the sort of total global emissions by something like 1%, which is very, very risky. Of course, maybe 0.8%. Maybe just kind of just one step sort of before that, obviously, just on the cement issue, just one last thing is that because you're dealing with something that is both requires knowledge of physics, knowledge of chemistry, knowledge of industrial processes, essentially, and obviously a lot of AI, it means that you have to have people working on it who, like teams that combine all of these areas of expertise together to be able to actually really solve the problem. So the key thing here is that what's called domain expertise, so kind of knowing a specific problem area, becomes extremely important. Having expertise becomes extremely important to really be able to use AI effectively. Now, for a very different example, I just want to talk about nature-based solutions a little bit, just an example here, and something about the oceans. So you may know the oceans are about 71% of the surface of the planet. But what many of us don't kind of think about a lot is that they do hold about 50 times more CO2 than the atmosphere. And they also are responsible for phytoplankton in particular, produce more than half of the oxygen on the planet. One kind of fact, or at least one thing that's often said about the oceans, is that we know less about the oceans than we know about outer space, which is true, and it's quite amazing. Right. Kind of specifically from oceans to talking about whales. Whales, of course, are the biggest animals on the planet. And with whales, absolutely so much more to explore in the oceans. So whales do a lot more than being kind of these amazing, majestic animals. They are actually extremely important in the carbon cycle, in the ocean's carbon cycle. I'll kind of give a bit more detail on that in a moment. But one thing kind of to note is that the number of whales in the world has dramatically reduced because of whaling over the last maybe 150 years or so. And actually, it's estimated that restoring them to their pre-whaling population could result in several gigatons of reduction of emissions in the world, or at least in terms of the balance annually. So question on, is there more CO2 because of fishing? Yes. So over whaling, this kind of whaling itself results in less CO2 being sequestered in the sea, in the oceans. So I kind of talk about whales and phytoplankton. So what's amazing here is that this relationship between these two. So whales are the biggest animal on the planet. Phytoplankton are one of the smallest, essentially, tiny, tiny things. But there's two ways that whales help in sequestering CO2. So each great whale in itself sequesters about 33 tons of CO2. And then essentially when it dies and sinks to the bottom, that's sequestered for centuries at the bottom. I kind of compares it to a tree. It's about 48 pounds of CO2 a year. Obviously, it's a massive difference. But the key way that whales really contribute to sequestration is that because wherever whales are, you have a bloom essentially of phytoplankton. So they do significantly increase the amount of phytoplankton that's in those areas. And phytoplankton are the biggest contributor to oxygen in the atmosphere and to sequestering CO2 as well. So it's 37 billion metric tons of CO2, or about 40% of all CO2 produced. And it kind of, in terms of equivalence, it's kind of going back to trees again, that's about 1.70 billion trees. That's 4 times the size of the Amazon. So if you're able to restore, or at least partially, or hopefully fully, the whales population, that would have a very significant impact on kind of our fight against climate change. Now, that's not, obviously, this is one example. There's a lot more to the oceans, a lot more about preserving the oceans and kind of other nature-based systems. But that's a really one, I think, is a really important example. So there's a company called Whale Seeker based in Canada. They do fantastic work on marine mammal conservation. So the founders are marine biologists who used to do a bit of statistical analysis, the data science, and so on, but saw the opportunity and the potential of using machine learning to be able to do things like just understand where whales are, understand their movements, their populations, to be able to track that. And these use cases are things that you need not just for conservation, but also for things like, if you're a port and you're seeing kind of where ships are going and kind of routing ships so that they don't hit whales. And that's, obviously a problem for everybody, to be able to do things like making sure that you don't disrupt their different life cycles. And the idea is that you used to do that with people manually sitting and sifting over many, many images and so on. And that took a lot of time. Now did a very highly automated version of that process, which basically cuts something like 95% of the time that it takes to identify them, which means that you can process much more data much more quickly and look at much bigger regions in a much more efficient way. Last thing kind of on that is that, the kind of the understanding whales is a part of a bigger problem is that we really need to understand things like the oceans because of even some of the solutions that are being discussed around, for example, growing certain sort of carbon sequestering or carbon absorbing things in the oceans that are not necessarily part of the natural cycle. All of these will could end up having many, many unknown effects or kind of unexpected effects on the oceans, but also on the atmosphere more generally. And before we start doing that, we have to have a much better understanding of actually what's going on in the oceans, what's going on generally, and how we might be able to affect them. But do check out Will Seeker. They do fantastic work, fantastic organization.